Asia is the native home of wheat, barley, oats, and all other true cereals except Indian corn. As man learned to cultivate wheat for bread, his foot became firmly placed on the threshold of civilization, using bread as the staff of life. As the cultivation of wheat expanded, civilization followed. Wheat has been ground into flour for over 5,000 years. In the beginning, a saddle stone arrangement was used in which the wheat was ground between an upper stone, held in the hands, and a lower, concave saddle stone. The quality and characteristics of bread made from this flour are shown here. Man's oldest continuously practiced industry is milling. It is a completely automatic manufacturing process to convert the wheat to flour.
This movie, The Amazing Art of Flour Milling, has been prepared by Bill Carter of the RJS Carter Company, Minneapolis, Minnesota, with the cooperation of the Department of Grain Science and Industry at Kansas State University, Manhattan, Kansas. Most of the equipment has been modified by Professor E.P. Farrell and many students and staff, and with his help, Professor Phillips, Dave Hammond, and many friends in the industry, this film has been made possible. Bill Carter has taken all the movies, edited, and prepared the film. The object of milling is to make the most favorable distribution of products from good, clean wheat. This diagram shows the endosperm portion from which we make the flour, which represents about 83% of the kernel, the bran, about 14.5% of the kernel, and the germ, which makes about 2.5% of the kernel. It is necessary to condition grain prior to milling by adding a small percentage of water to the grain and letting it rest for about 12 to 16 hours. This makes it possible to make a good, clean white flour free from bran and germ particles. Milling is done by grinding and taking the ground product and sifting it, making a separation. Each time the product is ground and sifted, we make flour. This is repeated many times. In a commercial mill, we use rolls and make the separations on nylon, silk, and wire on sieves. In milling, the products that we take off flour represents about 75%, about 24% bran and shorts, and about 1% germ. This movie shows many interesting shots inside the equipment in a flour mill. We hope after you have reviewed this movie that you'll have a better understanding of the amazing art of flour milling. Let's look at the movie.
Before we can have these amber waves of grain, the wheat must be planted. Wheat is planted about an inch or so below the ground surface and may be planted in any position. However, the grain always grows from the germ end of the kernel and will always grow up regardless of the original position of the seed kernel. Germination time may be only 5 or 6 days for this much growth under ideal conditions. In 3 to 4 months' time, the wheat is ready to be cut and harvested when moisture and maturity are correct. In our present high production society, all wheat is harvested and threshed in one operation with combines. However, there is no more colorful event in our history than the threshing rigs of 50 or more years ago, and we bring you now an early threshing scene. The bundles of wheat were pitched by hand into the threshing machine. The threshing mechanism consists of a series of shaking screens and beaters to break the wheat kernels away from the stems and chaff. A blower provides the air to separate the straw and chaff from the wheat and blow it into the straw pile. Power was provided by this steam traction engine. Regardless of the type of threshing method used, the purpose is to remove the wheat from the stem and to remove the chaff as shown in this hand threshing operation. And here, one stalk of wheat can produce 35 to 40 kernels of wheat from one seed. The modern flour mill is the first completely mechanized and automatic manufacturing process known to man in which the wheat is converted into flour without the direct intervention of human hands. Modern transportation of domestic wheat is made with trucks and railroad cars. Here a truck is being unloaded. The truck ramp is tilted up to allow the wheat to flow out of the rear of the truck. In railroad car unloading, the boxcar door must first be opened and the cardboard seal broken. A heavy shaker unit clamp is positioned on each end of the car to shake the car and make the wheat flow out of the side door. The car is tilted slightly and both a vertical and horizontal shaking motion is provided. The wheat is conveyed from wheat storage to the mill by means of a screw conveyor. The processing flow diagram of even a small mill is complex and involved. Let us look at a simplified diagram so as to better understand the milling process. The two left-hand sections in this diagram show the flow-through machines in the wheat cleaning and preparation part of the mill. The actual flour milling operations take place in the machines shown in the next two sections of the flow sheet. The storage and load out of the products are outlined in the final part of the flow sheet. The first machines are a magnet, milling separator, and stoner. Foreign iron pieces are removed from the grain by this magnet. The milling separator is a screening machine to remove particles both larger and smaller than the wheat. Here the operator is examining the oversized pieces of foreign material removed from the wheat. The screen provides this motion to make the separation. If you watch closely, you can see the wheat pass through the screen. The larger corn remains on top. The stoner removes the stones the same size as the wheat. Wheat and stones are separated by the action of this machine. Stones are made to travel uphill. Oats and weed seeds are removed on these machines. Wheat is removed from oats with revolving discs having pockets for selective separation. The wheat is picked up and the oats remain. In slow motion, we see the selective action of the separator with the oats being rejected. At the top of the disc, the wheat is discharged from the pockets. Rejected oats are discharged at the end of the separator. The seed separator is of similar construction, except the disc pockets are smaller. Seeds are picked up and the wheat is rejected. The seeds are discharged from the pockets at the top of the disc. Clean wheat is discharged at the end of the separator. Further cleaning is done on the entoliter and aspirator. Many milling products are conveyed by air, and this collector separates the air from the product. This entoliter machine destroys any possible infestation and scours the wheat. Air suction control is measured here. The wheat is being scoured in the entoliter cone. The cone is removed to show the revolving impeller. Under extreme slow motion, we see the action of the rotor as it throws the wheat out onto the impact ring. A view from below shows the impact of the wheat against the impact ring. A defective kernel of wheat is broken here. An aspirator is a machine to remove light chaff and hulls from the wheat by means of properly controlled air currents. Air is very important in the milling process, and many pounds of air are used to process each pound of flour. The grain cascades down through many air streams, and the light fractions are lifted out with the air. temper, and final scourer. The correct amount of moisture is added for proper milling characteristics. Accurate water measurement must be maintained. Water is applied at the tempering conveyor, and the wheat is thoroughly mixed. After tempering, the wheat is allowed to rest in bins for many hours. Just before milling, the wheat is given a final cleaning on a scourer. Inside the scourer, we see a slow motion study of the action of the beaters on the wheat. The wheat is conveyed in pneumatic systems much like a large vacuum cleaner. This is the pneumatic pickup unit. Wheat is separated from the air. An automatic scale is used to control the exact rate of flow of wheat to the milling system. Roller mills and sifters. The milling process starts at the first break rolls where the wheat kernel is first ground. Milling is a reduction system in which the product is ground, sifted, and purified many times before all of the flour is extracted. An extreme slow motion study of the first break rolls shows how the layers of bran are peeled off and the white endosperm is ground up into flour. These conveyors pick up the products from the roller mills and carry it along to the next processing operation. After grinding, the products must be separated on a sifter. Many sifters are necessary for the various separations required in the system. Sifters are made with stacks of sieves for the particle size separations, and the gyrating action causes the stock to flow across the sieve. The stock comes in at the top and flows down over one sieve after the other, with the fine particles going through the sieve and the larger particles staying on top. The sieve mesh determines the particle size sifted out. The internal sifter flow is shown in this chart. brake stock from the roller mill flowing across the sifter sieve. A slow motion close-up of the brake stock being separated on the sieve. The fine particles pass through the sieve. Below the sieve, we see the fine stock coming through the sieve. The stocks flow out of the sifter into these spouts, and samples may be taken to check the quality of separation. This is the flour stock. And this is the coarse brake stock for further processing. The next step in the flow is further classification of stocks on purifiers. The purifier actually makes 3 different types of separations: a size separation, an apparent density separation, and an air separation. The stock is introduced to the purifier on one end and distributed evenly across the inlet end of the deck. The purifier deck consists of a sieve assembly of various mesh sieves, with the fine sieves at the inlet end and the coarser mesh sieves at the discharge end. This provides a size separation. The action of the deck, as well as an airflow through the sieve, produces a density separation, and the airflow lifts up the very fine particles. Here we see the stock that passes through the sieves. This plexiglass purifier allows us to examine the action more closely. The stock is conveyed along by the action of the sieve, and the air suction through the sieve produces a stratification of the stock. The stock above the sieve is conveyed along, while the finer fraction passes through the sieve. Lightweight particles are lifted by the air suction and carried off with the air.